Hi everyone, this is the video for lesson 6.2. So in this lesson, we're going to be solving more complicated trig equations. We've solved some trig equations before. For example, if sine of theta equals root 3 over 2, we can find theta, right? You can draw the triangle and see where it lands and draw the picture, and then you would know that theta equals 60 and 120. Okay, so we've done this a little bit before. It's just going to have more steps than what we've done in the past, which is normally nothing. We just find theta. So let's take a look at our first example. So it says that 2 sine of theta plus 1 is equal to 0. So remember, what we're trying to do is get theta by itself. So we want to solve that for theta. So first we would subtract 1. Just like if it was a two-step equation, you add or subtract first. And then we would divide by 2. So we get that sine of theta equals negative 1/2. So before we draw our picture and talk about that part, we need to know, is this a restricted problem like it was in 6.1? So in 6.1, what did I say about what makes it restricted quadrants? Good, it has to be an inverse function to start. So in our original equation, did we have sine inverse? No, we didn't. So that means we're not going to have restricted quadrants. It's going to be just regular. So where is sine negative? In quadrants 3 and 4. So we're going to have two answers here because we're not restricted. Okay, so if we draw our triangle, we can see that our reference angle is 30. So to get into quadrant 3 with a reference angle of 30, we would have 210 degrees. And then to get into quadrant 4 with a reference angle of 30, we would have 330 degrees. And that's it. So we solved our equation for theta. We found the two values that are going to make that equation true. Okay, so like this problem, we had two answers. Sometimes we can have 4, sometimes we can have 6 or 8. It just depends on what type of equation. The ones that we're going to work on today aren't going to be that complicated with so many answers. Okay, so what I want you to do is pause and try the next example, which is pretty much just like the first one, and then when you come back, we'll talk about the answer. Okay, so I can't see that pencil very well. We get tangent of theta equals 1 over root 3. So if we draw our picture, we're positive in quadrants 1 and 3. So the reference angle is 30. So 30 and 210. Okay, so let's try some of the examples on the inside. Some of these get a little bit more complicated, like our first problem. Okay, so for this one we have sine of x times the tangent of x equals the sine of x. So for most solving equations that have more than one factor, we want to make it equal 0. Okay, so I'm going to move that sign over. So I'm going to subtract sine from both sides. Okay, so now I'm going to have sine x tangent x minus sine of x equals 0. So it's going to cancel out. So where to go from here? Well, we have a GCF here. Both pieces have sine in them, so we can factor out that sine. Okay, so that means we'd have sine of x times the tangent of x minus 1. Remember, when we're factoring it out, it's like division. So if we divide this by sine, it would just be tangent. If we divide this by sine, it's just negative 1. So just like we did in algebra, if you have a product equal to 0, you can make both pieces equal to 0 to solve for x. So now we split it up. So sine of x equals 0, and tangent of x minus 1 equals 0. So for this one, when does sine equal 0? Well, if we draw the quadrantal angle, so sine is 0 here and here. So that means for this part, x equals 0 degrees and 180 degrees. So for this half, we get tangent by itself. We'd have tangent of x equals 1. So where is tangent positive? Well, that's in quadrant 1 and 3. So if we put 1 over 1, we get a reference angle of 45. So we get that x equals 45 in quadrant 1 and 225 in quadrant 3. So for this problem, we had 4 answers. 0, 180, 45, and 225. And that's because we had 2 variables. Well, not 2 variables, but 2 functions. Okay, so why don't you pause and try this one over here. It's just like the one we just did. Okay, so move everything to the same side and factor out your GCF. Okay, so I know that pencil's hard to read, I'm sorry. So we ended up with cosine theta equals 0, so 90 and 270. And then you got cotangent equals -1, which I just flipped to tangent. And then you get 135 and 315. Okay, so let's go for our next one. Okay, the next one's a little bit more complicated, again. So for this one, we have no GCF. But if you look at it, we have squared, not squared, and no variable at all. So this is like x squared plus x minus 2. Okay, so if we have x squared plus x minus 2 equal to 0, we can factor it, which is what we would do if we're trying to solve for x in algebra. So remember, it's factors that times to be the last one and add to be the middle term. So what times to be -2 and adds to be 1? It'd be x plus 2 and x minus 1. Okay, so we're going to factor this just like what we would do here, except it has a tangent in it. So it would be tangent x plus 2 times the tangent of x minus 1 equal to 0. Okay, and now we can split it up just like we did up here. So we would have that the tangent of x plus 2 equals 0 and the tangent of x minus 1 equals 0. And then solve each one separately like their own equation. So here, if I subtract the 2, I get tangent of x equals -2. So tangent is negative in quadrants 2 and 4, but -2 over 1 is not one of our special values, so that means we're going to have to use our calculator to help us figure it out, and we'll have a decimal as an answer. Okay, so if we take the inverse, we would have tangent inverse of -2. So we get that x equals -63.43 degrees. Okay, and your calculator is really smart, and it knows that like the reference angle is going to be negative because tangent was negative, so that's telling you, that it should be in those quadrants because tangent's negative. Okay, so that's not our final answer because we want a value between 0 and 360. I know I didn't type it on here, but usually they say that your answer needs to be between 0 and 360. Okay, so we need to get our answer in quadrant 2 and the answer in quadrant 4. So remember, in quadrant 2, it's 180 minus your reference angle. And in quadrant 4, it's 360 minus your reference angle. So if we do 180 minus 63.43, we'll have our quadrant 2 answer. So quadrant 2, we have 116.57. And then 360 minus our 63.43 is 296.57 degrees. So those were our 2 answers from this part. Now we have to go back and solve this part. So solve for tangent. Tangent of x equals 1. So when does tangent positive, or where is tangent positive? And we'd be in quadrant 1 and 3. And remember, if it has tangent equals 1, it's 1 over 1. So that gives us a reference angle of 45. So we have 45 in quadrant 1, and then 225 in quadrant 3. Okay, so let's take a look at the next one. I'm going to want you to do it by yourself, but I'll help you remember to do the factoring. If you remember how to factor with the number in front, then go ahead and pause and try to solve it on your own. Okay, so we have 3x squared minus x minus 2. So remember, when our leading coefficient is not equal to 1, we have to factor a little bit differently. Okay, so it's not just what times to be negative 2, but it's what times to be negative 6 that adds to be 1, negative 1. So if we list our factors, we would get that negative 3 and positive 2 times to be negative 6 and add to be negative 1. Okay. If you do the trident method for factoring, this is what we're doing here. If you factored some other way, then factor however you learned. Okay, so in this method, we take the leading coefficient and put it with our x's in each one, and then we reduce out the extra factor. So in this first parenthesis, there's an extra factor of 3, so we can divide out that 3. So we get x minus 1 times 3x plus 2. So this is the factors of this. Okay, this one doesn't work because 3x times 3x is 9x squared, but we want a 3x squared. So we got to get rid of that extra factor like we did here in step 2. So this is how we would factor this. So if we go back, we would have sine of x minus 1 times 3 sine of x plus 2 equals 0. So go ahead and split it up. From this half, you're going to have to use your calculator to get a decimal answer. So pause your video, solve it, and then when you come back, we will go over the answer. Okay, so over here we got sine equals 1, so 90. Here we got sine equals negative 2/3, so we're going to be in quadrants 3 and 4. Okay, and then when we do it in our calculator, you're going to have to add that value to, we get negative 41. So you're going to have to add 41 to 180 to get it in quadrant 3, and then subtract it from 360 to get it in quadrant 4. Okay? Okay, so let's take a look at the bottom ones. So these are a little bit more complicated again. They're not already in the form like the last two were where you could factor it straight away. Okay, so we have to do some extra work here. So first I would distribute and then move everything over to the other side. So cotangent times cotangent would be cotangent squared. Cotangent times 3 would be 3 cotangent. And then I'm going to subtract the 1 to the other side, so we would have minus 1. Okay, so from here we would try to factor. So we would have x squared plus 3x minus 1 equals 0. But that's not factorable. Nothing that times to be negative 1 is ever going to add to be 3. So if you think back to algebra, what did we do when we weren't able to factor? We used the quadratic formula. So that's what we're going to do here. We're going to solve this using the quadratic formula. So remember the formula is negative b plus or minus the square root of b squared minus 4ac over 2a. Okay, so when we plug in, we're just plugging in the leading coefficients. So a is 1, b is 3, c is negative 1. So go ahead and plug those in and simplify. I'm going to do it real quick. So if you want to do it on your own, which you should, pause your video. So we get negative 3 plus or minus the square root of 9 plus 4 over 2. So x is equal to negative 3 plus or minus the square root of 13 over 2. But if you think back to the original problem, we didn't have just x, we had the cotangent of x. Okay, so really what this says is cotangent of x equals all of that stuff. So this obviously isn't a special right triangle, so that means we're going to have to use our calculator to find our answers. Okay, so since it has the plus and minus, I'm going to split it up into two different pieces. So we have that the cotangent of x equals negative 3 plus square root of 13 over 2. And the cotangent of x equals negative 3 minus the square root of 13 over 2. Okay, so I just split up the plus and the minus. Okay, so now we have cotangent, which makes it a little bit more difficult, but remember we can flip it to make it tangent, and that'll make it a little bit easier to type it in your calculator. So I'm running out of room, so I'm just going to do it on a separate sheet of paper. So let's look at this first half. So this would really be the tangent of x equals 2 over negative root 3 plus root 13. So then we would do the inverse to get x. So let's type in 2 over negative root 3, or negative 3 plus the square root of 13. So we need to determine if this is going to be positive or negative, because that tells us where tangent's supposed to be, what quadrants. So I got that this is equal to a positive 3.3. So that means I know that this is in quadrants 1 and 3. Okay, so now I'm going to do the tangent inverse of that. So I get that x equals 73.15. So that's my quadrant 1 answer. And then to get into quadrant 3, I'll add 180 to that. So we have that and 253.15. Okay, so that is from the plus version of our formula. So now we have to do the minus. So I'm going to flip this one again. So now I have the second half, tangent of x equals 2 over negative 3 minus root 13. So I'm going to type it back in. I'm trying to go back, but it won't let me. Okay, so 2 over negative 3 minus the square root of 13. So we get that this is a negative answer. So now I know that my quadrants are 2 and 4. And then I'll do the inverse. So tangent inverse of that answer. And so I get that my answer is negative 16.85. So remember, that's just our reference angle. So to figure out what it is in quadrant 2, we would do 180 minus 16.85. So I have 163.15. And then 360 minus, so 343.15. Okay, so from this problem we got those 4 answers, the 2 from up here and the 2 from down here. Okay, so I know that that one was complicated. Doing the quadratic formula with the trig functions is hard, especially when it comes out to such a crazy answer. You got to figure out where the quadrants are and all that. So we'll practice some more of those in class. Okay, so let's take a look at our last one, because this one is different yet again. Okay, so sometimes you're going to run into an equation like this where it has different trig functions. So to be able to solve it simpler than what we have to do this one, they have to be the same, like cotangent, tangent, sine. Okay, remember up here when they were different functions, we had to like factor it out to make it work. But on this one, we have nothing to factor out because they're both to the first power. But if we remember our identity is, we know that the tangent squared plus 1 is equal to secant squared. I think. I don't know what my identity sheet is. I'm pretty sure that's what it is. Okay, so what we need to do is simplify this to make it, or change it to make it where we have it's squared, so we can use this to turn it where it is all tangents or all secants. Okay, so I know if I had a secant squared over here, then I could replace it with this. So what we're going to do now is make it where we have a secant squared. Okay, so I'm going to square both sides to get my secant squared to be able to use this identity. But unfortunately, that means on this side, I'm going to have to FOIL. Okay, so I'm not going to show all my steps, but if you need to, do it on a separate sheet of paper and write it in. So if I FOIL this, I end up with tangent squared plus 2 root 3 tangent plus 3. And then on this side, we just have secant squared x. Oh, I forgot my x's. Okay, so now that I have it squared, I can use my identity. And secant squared equals tangent squared plus 1, so I'm going to plug that in there. So now I have tangent squared x plus 2 root 3 tangent x plus 3 equals tangent squared x plus 1. So I don't know if you see it yet, but we just won the lottery here, because what happens when we subtract those tangent squareds? They're gone, so now we don't have to factor or do the quadratic formula. We just have a regular problem, which makes everything so much better. So before I rewrite, I'm going to subtract this 3 and move it to the other side too, because now it's just a linear, so it's like solving a two-step equation. So I have 2 root 3 tangent x equals -2. Divide by 2 root 3. And the 2's will reduce out, so I'd have -1 over root 3. And I can draw the picture. So tangent's negative in quadrants 2 and 3. -1 over root 3, so that's 2. So our reference angle is going to be 30. So in quadrant 2, we have 150. In quadrant 3, we have 330. And that is it. So sometimes you have to do some special tricks to make it work. Okay, that is all for 6.2. We'll practice some more in class tomorrow. Warner out.